Good morning, students. I am Karkurali, Assistant Professor from EEE Department, RMD Engineering College. Let's move on to the topic.
Today we are going to discuss about impedance and reactance diagram problems in power system analysis. And this is the first problem. We will discuss this one. So in this problem, impedance and reactance diagram is asked to draw. Then here now choose the generator as the base. So here we can choose the ratings of the generator as base value, and then 3-phase and line to line ratings are also given here. So if it is single phase, we have to convert it into 3-phase. Now the ratings are themselves are in 3-phase and line to line ratings. In generator, in all these 4 components, the reactances are in per unit value. If the reactances are given in percentage, we can take these as given in per unit value. Only line value is given in ohmic value. Then the very first thing, we have to form the sections. Okay, so sections are formed with the help of the transformer, because the transformer vary the voltage level in each section. So the primary winding of the transformer 1 and along with the generator makes one section, because they are all at a 1 voltage level. Then the transformer steps up the voltage to 200 volt, correct? See, 200 volt here. So transformer T2, the primary is having 200 volt. So now the primary winding of the transformer 1 and secondary winding of the transformer 1 and the primary of the transformer 2 together forms section 2, because they are all in the same voltage level. And transformer 2 secondary winding and motor are in section 3. Okay, now we formed sections. The problem is having 3 sections, and procedure is, the first thing we have to select base power. According to this problem, the base power is 100 MVA. Then we have to select new base voltage for various sections. These new base voltage is formed with the help of the these 2 formulas. Okay, and then we have to, third step is we have to find out the reactances, new reactances per unit, correct? If the reactances are already in per unit, we have to use this formula. If the reactances are in ohms, we have to use this formula. Then we can draw the impedance and reactance diagram. Here I have given the ratings below of the generator or all the components. I have written all the ratings here. Now, as we already discussed, first step is to find out the base power, correct? So the base power is 100 MVA, which is already given in the problem, correct, to be taken as generator base. So for the entire section, 100 MVA is the base power. Okay, then we have to find out for each section what is the base voltage. First, step 1, so step 1, we have found out new base power is equal to 100 MVA. So this is the step 1. We have found out this one. Okay, so second step is finding out new base voltage for various sections. Finding new base voltage for various sections. So how many sections we are having? 3 sections, correct? For all the 3 sections, we have to find out the new voltage with the help of the transformer ratio. So the formula is given here. See, this is a formula. Now for section 1, we will find out for section 1. So section 1, we know section 1 lies here. What is the base voltage given, generator is connected in the section 1, so section 1 new base voltage is 20 kV, we can take it as 20 kV. So kVB new, kV, so we can write here B in suffix, correct, new is equal to 20 kV. This is for section 1. Now for section 2, no, what is section 2? How will you find out? With the help of the transformer ratio. So in section 2 HT winding is available. With the help of the voltage on the LT section, we are going to find out for section 2. So which formula we will use? No, KVB on HT section. This formula we have to use. KVB on HT section is equal to, use this formula, KVB on HT section, correct. Now section 2 lies in the HT of transformer 1, hence we will be using this one. Okay, now equal to, what you get, equal to KVB and LT section we have found out 20 multiplied by HT voltage rating. What is HT voltage rating? 200 divided by 20, both gets cancelled, 20, so you will get only 200 kV. This is for section 2, correct, this is for section 2. So similarly for section 3 we have to find out for section 3. For section 3, no, section 3, the secondary winding of the transformer 2 lies in section 3, which is nothing but LT section. Now KVB on LT section, the formula to be used is KVB on LT section. We are going to find out KVB on LT section of transformer 2, correct, hence we have to use this formula. Okay, now substituting the values, no, here is equal to KVB on HT section. What is in HT section? Which is lying in the section 2. So 200 multiplied by LT voltage rating is 20 divided by 200. So you will get this as 20 kV. Hence we have found out now for section 1, section 2, section 3 new base voltage. Okay, now I can split this like this. This is section 1 and this is section 2 and section 3, and their corresponding new base voltages. Here it is 20 kV, and for section 2 just I am representing here, nothing else. Okay, so 200 kV. For section 3 it is again 20 kV. Now I have found out new base power and new base voltage. Now we have to find out the per unit reactance. This is the third step, correct. So I'll delete everything. Okay, now step 3. Okay, now step 3 is finding per unit value for all the components, So what are the components available? See, these are the components. I will highlight these things with this. Okay, now this is one component, another component is transformer 1, another component transmission line, transformer 2, and then motor, correct. Now we are having 5 components in this single line diagram. So for each component I am going to draw. Okay, so what you will get here, no, first component is generator. Okay, so first component is generator, so I will put here as first as G. First as G1, correct, G1. Now the G1 reactance is given in per unit already, correct. 9% means I already told it is per unit. So which formula we will be using? For this, if the per unit is given, then we have to use this formula. So this one I will be using. See, now I have to substitute all the values here. That is enough. Okay, now substituting all the values in the formula, correct? Old per unit impedance is 9%, no? So 0.09 multiplied by old base voltage. Whenever the subscript old comes, no, we have to refer the rating of the particular component. So old base voltage of generator is 20, new one is also 20, the whole square, correct? So you have to put the square, then multiplied by new base power and old base power. Both are same because generator is considered to be the base, correct? So both are same value. So solving this one, we will get as 0.09. Okay, we can put either in terms of J or simply we'll put here. Okay, now the second component, similarly the second component is transformer 1. The transformer 1 is also represented in per unit, so again we'll be using the same formula. So directly I will substitute now for this. So ZPU new, I hope you will understand this. Still ZPU new for transformer 1 is equal to ZPU old. What is it? ZPU old 0.15 multiplied by, now while you take for transformer, no, the old base voltage, it is, yeah, I told you to refer the ratings, correct? Now there are two voltages in the transformer, primary side as well as secondary side. We can consider any one, either 20 or 200, but the thing is, while you consider new base voltage, where you should which section you have to take, that you have to consider. If you take 20 kV as old base voltage, it lies in the section 1, so you have to consider section 1 new base voltage. If you take 200 kV as old base voltage, this winding lies in section 2, so new base voltage for this section is 200 kV. So first I will take 20 kV. Okay, so old base voltage is 20 kV. This lies in section 1. So the corresponding winding lies in section 1. The corresponding new base voltage is to be taken as 20 the whole square. Okay, 20 the whole square. Then again multiplied by old new base power divided by old base power. New base power is 100 for entire section. Divided by old base power is, see, for transformer what is the old base power? 90. So divided by 90. The answer for this is 0.17. Okay. Then similarly we'll go for the third component. Third component is line, correct? For line, no, we are given with ohm, correct? You are given with ohm. So which formula we have to consider to find out the new base voltage? For this, ZPU new is equal to this formula you have to use. So this formula, just substitute directly within this. So what you get is equal to Z value. What is Z value? 120 multiplied by new base power is common, correct? Divided by new base voltage. Line lies in the section 2, so its new base voltage is 200 kV, correct? So 200 square. So 200 square. So solving this, we will get 0.3. So for the three components we have found out. Similarly, we are going to find out for the remaining components also. So then fourth component, we will go for fourth component. So fourth component is transformer 2, correct? Transformer 2, its reactance is again given in per unit value, so we have to choose the first formula, correct? So just substitute the value, we'll get the answer. So what is its old per unit impedance for transformer 2 is 0.2 then multiplied by old base voltage. I told old base voltage we can take either primary or secondary. So if I take primary, okay, 200 kilowatt, it lies in section 2, so new base voltage is 200. So both us here 200 divided by 200 the whole square multiplied by new base power, which is common for all, correct, the entire section. Old base power for the transformer 2 is again it is 90 MVA, okay, equal to, solving this we will get 0.22. Then last component, fifth component is motor. So motor per unit impedance is given, correct, reactance is in per unit. So again we use the same formula, above formula, and just we can substitute here with the help of the above formula, correct, just substitute in that formula. So for this ZPU new is equal to, what will you get, old per unit impedance is 0.08, 8%, no, 8% should be converted into 0.08, and then old base voltage, it is having a one voltage only, so old base voltage is 18, new base voltage for section 3, motor lies in section 3, hence we have to choose 20, correct, 20 the whole square, okay, 20 the whole square, then multiplied by new base power is 100 divided by old base power is 90, correct, old base power is 90. So solving this we will get equal to 0.07. Now we have found out per unit impedance for all the 5 components. Then we have to draw the diagram, impedance diagram. For impedance diagram, no, I am having the final diagram here itself. I will take this diagram. This is a impedance diagram. This is the impedance diagram. We know equivalent circuit for the generator. Now see, this is the equivalent circuit for the generator, where the first component is represented by like this, generator, and the second component is transformer. After generator 1, transformer 1 is connected, which is connected in series. See, this is for transformer 1, this reactance is for line, transmission line, and this is for transformer 2, and after transformer 2 motor is connected. So this is the equivalent circuit for the motor. Like this they are connected. So this is nothing but impedance diagram. Now the reactance diagram, no, reactance diagram and impedance diagram are same here, because in impedance diagram there is no load is given or no resistive load is given. So the same thing can be represented for the reactance diagram. Okay, in this case impedance diagram and reactance diagram are same only. Okay, thank you all.